Hello everyone. So, welcome to the next class. Now that we have understood the Kaya entity and we have also understood that what kind of limitations Kaya entity might have to work in, but let us start now looking into various aspects which we can then start working under Kaya entity. And because that is the kind of a bigger paradigm that we are taking, that we can start looking at the things at a more holistic level or at a macro level, and from that macro level then we can try to come down to look at the things at a more micro level. So, one of the first verticals that we will look into under Kaya entity would be energy efficiency, or reducing the amount of energy which is needed to be used per unit of GDP. So, let us quickly recall what Kaya entity was. So, it was a tool which was basically helped us to break up the greenhouse gas emissions into 4 major verticals, which was around population, GDP per population, then energy per GDP, and emissions per unit of energy. And as you can imagine that since population would lead to consumption, GDP plus by population is nothing but consumption. Energy by GDP would have two kind of aspects to it. One would be consumption related, one would be technology related. So, when we look into energy efficiency, which is primarily this vertical, which is energy per unit of GDP, we will look into both aspects of it, how consumption can influence it and how technology can influence it. So, first we will look into the aspects of from the consumption side, and then we will looking more into technology side of it. So, just to quickly recap that what we also see here is that on the energy efficiency side, or the energy which is needed per unit of GDP from a technology side perspective, there has been some efforts on that line and we already seeing some improvement on those lines, but that has been negated by a huge rise in consumption which we have seen of late, and also since population is growing. So, overall global CO2 emissions have continued to grow. That is what is very evident from the data that we have around us. So, before we go into that, since we are looking at consumption, the first vertical that we are trying to look into. So, let us recall what climate change is. So, climate change, as we have seen, that is closely related to energy production and consumption, and specifically they have risen a lot because of the fossil fuel based growth models. And when we have looked deeply into this, so it kind of looks a very structural feature of the modern economies, where priority is for continuous expansion. So, our whole society, if you see that way, have been woven around a model of consumption. Uh, uh, from the start of almost the industrial era, or even before that, we have continuously talked about kind of a way to live, which is totally a consumption based model. And kind of a policy question which kind of arises here, or academic question which arises here, is continued economic growth is needed or is compatible with economic or environmental viability, is a fundamental question which kind of bothers a lot of researchers, a lot of policymakers these days, that while we understand that the growth is needed, because till the growth does not come, the quality of life will not improve. A lot of people are still living below poverty line, so they have to come above the poverty line, and economic growth is the way for them to come within the this paradigm of better quality of life. But is that a viable model? Is that a model where we can continuously continue to grow and still become environmentally viable also? So, that's a question which is academically bothering a lot of people of late, and earlier also. So, on this there are two models which has been discussed, and we will look into those two models on a one by one basis. One is actually a degrowth model, where we say that no, hang on, we don't need so much of growth. We say that this so much of growth was never needed. It is only because of the whole consumption thing which has been pushed into our mindset, which is leading to such an exponential growth. And actually, we don't need to grow so much. We can live life with lesser amount of resources that we have right now, at least on a per capita basis. On a per capita basis, our consumption has grown into some kind of a limit which is unsustainable. And since this is a growth which is unsustainable, we can basically push back, and we can look at a very transformational way of living, which is where we can look into degrowth of the whole economy, or the whole society altogether. The second model which talks about is no, that is too transformational approach, and that is too drastic an approach. Let us talk about something what is known as a green growth. So, we continue to grow, but growth is compatible and it is more reformist, and where we say that the growth will happen, but it will happen in a more kind of a structured way, in a more greener way. And let us look deeper into this. So what is green growth being talked about is that green growth basically talks a lot on the technological innovations. It basically talks that we will continue to grow, but since we are now a much more mature society, we are a much more strong technology base has been set up for us. We have so much of technological know-how available with us. Why can't we develop technologies which can help us to grow, but help us to grow in a more greener way? And for that, there is a lot of dependence on technology innovations like renewable energy systems, energy efficiency improvement. Electrification is being talked a lot. A lot of things should move to electricity from fossil fuel based energy sources or some other energy based sources, and moving to electricity has as advantage, because then electricity can potentially be generated through renewable energy sources, and they can be utilized more responsibly. Second is more policy based instruments, which are where we have talked about carbon pricing, we have talked about emission trading, we have talked about environmental taxation, that one part of the world can continue to grow more responsibly, other part of the world which needs to grow more aggressively can actually be supported by the part of the world which needs to grow more responsibly. And through some trading of this carbon exchange and all those things, that we can manage the carbon at a worldwide level, and that is how we can go for a more structured approach in terms of where we continue to grow, but we grow more greener, right. Basically, in this case, the whole climate action is seen as a investment and not as a cost, because then basically what you are saying is that we have this opportunity to grow, but since still some part of the world needs to grow, and where the investments needs to go, so let that investment happen in form of the greener technology investment, which are funded in turn by the part of the geography which is already developed, which doesn't need to grow that much. So part which needs to grow can grow more systematically. So that way, whole this climate action can be termed as a investment and not as a cost, because we need growth, and we just grow more responsibly and more greener, right. So it is, in a way, the crisis is seen as a structural green transformation opportunity, rather than being seen as a burden on this whole transformation. So the core logic of this whole thing is that it works on improving human well-being, social equity, while reducing environmental risk. That's the kind of a notion on which this green growth theory is working around. It says that we need to have economic growth, but with ecological constraints. And the logic here is that if we don't have economic growth, where will we get money to do this transition? And it also assumes that this growth and environmental protections are not incompatible. They are compatible. We could grow in a manner which is more responsible. So there is a word called responsible growth also, so which talks about that while we are growing, we are not growing in a manner which is irresponsible, that like we have been growing in the past, which is completely fossil fuel based economy that we have been growing. We grow more responsibly, and we grow in a manner where we apply new technology in a more greener fashion. And the kind of constraint, so how environmental is protected here is that environmental failure, so environmental degradation is taken as a failure model here. So this is used as a kind of a constraint in this whole model. So either it could be constraint, or this could be a limiting factor, that the emissions, the CO2 emissions cannot go up, that is not allowed. That is one kind of a limitations which is put in a lot of this model when model is developed around what kind of transition can happen from point X to point Y. Let me give you an example. Suppose there is a city which needs to now have X gigawatt hour of further energy to maintain its power supply to the new growth which is happening with respect to industries, with respect to new facilities which are coming up. So instead of making them dependent on fossil fuel based energy sources, so they will be working on renewable energy based sources, and in that renewable energy based sources you will use carbon dioxide as one of the constraints when we do this modeling. Then of course another constraint would be in terms of how much cost can you incur for this transition, and then so because the cost has to be incurred on this transition. So is that cost more than the fossil fuel based cost, or can we put also a limit that where we can develop a kind of a two-step model where we talk about that our cost needs to be same as the current cost of this fossil fuel based energy resources. We will anyway need to put gigawatt hour. For that, either we use fossil fuel based resources or we use non-fossil fuel based resources. So can we put a double constraint here, that we put cost as one constraint and carbon dioxide as another constraint for developing this transition model. So in this whole model, what is done is that we talk about reforms rather than replacement as the existing model. And so this is one way people are saying that, see, degrowth cannot be a model, because that will be too drastic approach and people will revolt. Some part of the society which is not grown will revolt against it, and that may not be a sustainable way for us to move forward for this. So when we talk about this, we kind of a decoupling. So basically what we are doing here, we are saying there is a strong correlation, as I have shown earlier with data also, which talks about the GDP plus and CO2 has a positive correlation to it. And so as GDP grows, we have seen this carbon dioxide emission continues to grow. What we are talking about in this model is that let's decouple these two things, that R value, coefficient of that should be reduced and should be made, either should be negative or it should be non-dependent. So there are two models which are talked about. There is that we need to talk about decoupling. Now there are two kind of decoupling that people are talking about. One is absolute decoupling and second one is relative decoupling. Absolute decoupling is where we are saying that the environmental aspects either reduces or remain constant in absolute terms. So though my GDP is growing from point X to point Y, the carbon dioxide either remains here or it grows down. So we are the two aspects are getting completely decoupled. So either we are approaching towards correlation coefficient being either 0 or approximately 0, or we are saying that correlation coefficient is less than equal to 0, which is on the negative side of it. So that's a very strong decoupling. So where we are saying that we grow, but we grow in a manner in which we completely decouple the two aspects. The second is the relative decoupling, that we continue to grow, both rise, but the slope of the curve changes. So if we just take both these axes, that is the growth, and in this our GDP is growing at a certain pace. Suppose GDP is growing at this pace, and suppose the carbon dioxide is on this axis, the carbon dioxide is growing at a much slower pace. So in a way the two things gets decoupled. The correlation still is there, but the correlation coefficient is much lower. It's kind of a partial coupling, which talks about that we both rises, but the second one rises more slowly, and it indicates that the carbon dioxide will continue to increase, but will increase much slower compared to business as usual scenario. So these are two models which are talked about. If you talk in terms of environmental outcomes of these two cases, absolute decoupling will reduce total environmental pressure, because that will start talking about negative correlation or talking about zero kind of a correlation. So we, in a way, we enjoy that GDP is growing and the money is flowing into system. We are getting money for further investments, but at the same time carbon dioxide has been kept in check. And relative decoupling only moderates the rate of growth of the impact. From an absolute sustainability perspective, if you talk about sustainability as a classical definition, complete decoupling would be a ideal model to have. But is it too drastic again? Like degrowth is a model where we were talking about it being too drastic. Is complete decoupling also a very drastic model to have? Is it even technically feasible to have those kind of technologies coming in, where we continuously decouple our GDP growth to carbon dioxide emission? Like we are saying that carbon starts getting absorbed in the system rather than getting emitted in the system. So we are talking about a very, very drastic technology changes here. We are talking about really state of the art technology, which can then suddenly change the processes, change the way we grow things, change the way we manufacture things. It's a very strong technological changes that we are expecting to happen. The second one seems to be again a more feasible approach, and again there are critics around it. Critics say that since world is comfortable living the way it is living right now, so what doesn't want to take some strong calls, and that's why not enough money is being put into this degrowth model or absolute decoupling model. But the fact of the matter is that world still is trying to do the transition with respect to relative decoupling model. For policies also, policy side also, as you can imagine, there will be very strong policy framework which will be needed if you need complete decoupling to happen, and we will need a very structural economic transformation which will happen. So this is a very transformational kind of an approach again, and it is still not seen a lot of success. What has seen more success is kind of relative decoupling. So where are we right now? So green growth relies on absolute decoupling, GDP increases, total emission or resources decline, but since the central question remains unsolved, that can absolute decoupling occur at the scale and speed required, because we are talking about technologies which needs to be developed at a very rapid pace, which needs to be so transformational technologies that they can help us achieve it. It's very rare or difficult to achieve, and relative decoupling is more commonly observed in the current societal structure right now, the way we are things happening. So when we start talking about energy efficiency, when we start talking about energy intensity, when we start talking about this technical changes also, what you will see is that we will not talk about absolute decoupling as a normal example. What we'll mostly talk about is relative decoupling, where the growth rate of CO2 has been kind of decoupled, or not decoupled, decoupled is a strong word, partially decoupled, and so just the rate of the growth of CO2 has been reduced compared to what would happen in business as usual scenario, right? So with this context, so what we have talked about is that there are two models which are being talked about. One is a degrowth model, which we think is very transformational. So we are not talking about it right now. I'll come back to this later on just to understand where do we stand against this thing right now. Then in terms of decoupling also, then there is absolute decoupling, which again we think that it's too transformational and that may not be available at the pace that we need it to be. So we are mostly talking in terms of relative decoupling, where the GDP is growing, the CO2 is growing, but at a slower pace. So GDP is growing at a much faster pace and CO2 is growing at a much slower pace, rather than they both growing at a kind of a similar pace, or the pace at which they have been growing so far. Okay, so now since we have understood that, let us now start looking into deeper understanding on this subject now. So first topic that we will cover under this would be energy intensity and energy efficiency. So energy intensity or energy efficiency in the net zero transition mode is what we will talk about, and that what we will also talk about, that why demand side matrices matter so much as much as clean supply do. So we are not talking about renewable energy here, like, so you need to be careful when we talk about this thing. We are not talking about renewable technologies here. What we are talking about is that we will continue to use energy but in a more efficient way, or we will somehow reduce our energy intensity. So what is the definition of energy intensity is that how much energy do you consume per unit of GDP. So we are working that as a matrix here, and what we are talking about is that can we make our energy systems more efficient so that we use less energy to do the same amount of work. So we are talking about in that framework, but we are not saying here is that how we are generating that energy. So just be careful here. A lot of students get confused, that they start talking about solar cell or wind or batteries or some of those technologies as an example for energy efficiency, energy intensity. They are not. They are basically talking about, can you reduce the amount of energy that you need to for the end use. So what is end use in usual case? End use is light, end use is heat, end use is the distance that we need to travel in our car. So those are the end uses. So for those end uses, for this, you remember if we were earlier talking about terms called efficacy. So it is basically how efficiently are we able to use our system, end use. Now since we have that end use, what we are simply trying to do is that, can I use less amount of energy for the same end use? I am not saying how that energy is generated here. That is not at all a discussion under energy efficiency and energy intensity as a topic. For that we will come separately, and where we talk about the carbon intensity of the energy. So now let us understand why energy efficiency is central to energy transition, and that is a topic which has been kind of ignored by the world for a very long time. But now world is waking up to this fact that actually energy efficiency can be a very powerful mean of overall this carbon transition is. In a way you can think of that each unit that you save is in a way each unit that you generate. So this kind of becomes a greenest unit for that you can generate. See, whenever you move from fossil fuel based energy to renewable based energy, you still need to generate that unit to consume. What we are saying here is that do something in the technology that you don't need to use that unit at all. If you don't need to use that unit, you can use the same unit for doing something else. So we are saving one unit, then using one unit. So instead of 2 units that was needed for the work, you are effectively working using only 1 unit. So this is kind of the greenest way of energy production, because you are not putting any resources. Even if you use solar cell to generate 1 unit, there will be some embedded carbon. There will be some carbon which will be generated through the process, through transportation, or something else will lead to some carbon generation. If you save 1 unit, you are saving 1 unit directly, and that is that. So that's why it is called the greenest unit that you can generate. It can have many other advantages, that it could be very cost effective fulfillment of energy need, because in a way what you are saying is that you are saving on energy. So since you are saving on energy, so in a way you are reducing the overall cost of energy system, because then you are able to meet the need of society with lower amount of energy consumption. So it means you are able to meet the societal need at lower economic cost, and you will reduce utility bills. You will also be moderating price volatility also, because the consumption is not that high. So from a demand supply perspective also, it kind of helps. And since from a demand supply point it helps, it can help to reduce the price of the other units also which you are consuming. So that is one very interesting paradigm that it can happen from that side. It directly leads to decarbonization and environmental performance, because one unit is consumed less. So effectively what you are saying is that, as I already gave you this example, that you need to produce less, and you need to produce less is the best way to reduce our emission. It also leads to energy security and risk reduction, because since the organization, the country, or the whatever entity which is using this energy, they need to use one unit of energy less, and if they depend on that energy to come from outside, from somewhere who is a third party supplier, so now they need to procure one unit less. If as soon as they need to procure one unit less, in a way it gives them more control over the number of units that they already have, because then they can utilize those units for something more meaningful that they could have used it for. This in a way lead to a huge big situation where you can reduce a risk overall of supplies, because now you need to procure lesser. As soon as you need to procure less, you will have more bargaining power, and you will also have the power where you can be more control of your supplies. Next thing it can also do is that it can lead to power system optimization and infrastructure avoidance also, because if you need to consume more units, you need to have a system through which you need to supply those units also. And if you don't do that, so we can talk about sustained demand reduction can lead to infrastructure reduction also. So there are a lot of benefits which kind of comes under this. But what you need to you need to be careful about is that these benefits only arise when efficiency reduces absolute energy demand, not merely energy intensity. And I talk about more about this going forward, that energy intensity can be a very misleading term, and energy intensity is, though it is a lot talked about term, but it can be a very misleading term, and I'll come to this in the next couple of slides, that if you are really talking about all these advantages of energy efficiency, then it needs to reduce absolute energy demand. It cannot be simply a energy intensity shift, that we reduce our energy intensity, because energy intensity can reduce by many other factors also. So that we need to be careful about. So efficiency, just continue to talk about efficiency. This is now IPCC is also realizing this, that this is in a way, IEA is also saying it, IPCC is also saying it, that in a way it is so called first fuel. It is the first fuel, because this is the fuel, these units are already generated by us somewhere. We don't need to generate any more units. So this is in a way first fuel. It is most expensive and abundant, because we have so many of units which are flowing around us, and as soon as you start saving one unit, in a way you have that unit available for something else. IEA talks about it, that we call energy efficiency as the first fuel, which shows its significance. So that's a kind of seriousness which has come around whole of this efficiency paradigm of late, which talks about that if you can really work on efficiency measures the way you should, or which we can potentially, this could really lead to a kind of a game changer. And I'll show you through some of the data that this is a thing which is talked about a lot when we are talking about this net zero transition. However, just another word of caution here, that first fuel doesn't mean the only fuel. Efficiency lowers the scale of transition, but cannot substitute fuel switching on clean supply. So again, that's a kind of a caveat which I'm giving you, because some students again get confused, which I told you in the first slide also, is that students get confused that as soon as you are saving on energy, you are making clean energy also. No, you need to invest separately on generating clean energy, which will be another topic of discussion later on in the course. But just understand that first fuel does not mean the only fuel. So it is not that only through energy efficiency you can achieve the carbon neutrality. You will need to generate whatever energy is left to be used. You will still need to generate that in a cleaner fashion. That again, I'll come to that later on, but just wanted to make sure that you understand that thing. What will be its impacts? In terms of climate impact, it could also mean that it will reduce the fossil fuel use, both for generation as well as for end use. And it is expected that this could be delivering 40% of required global emission abatement by 2040, as one of the estimates by IEA, that it could be huge impact in the overall this transition of the net zero transition that we are talking about. It could be as high as 40% as per IEA. And in fact, efficiency gain over last 2 decades has avoided almost 8 gigaton of GHG emission. You remember the earlier curve that we were talking about, that the efficiency actually has been improving. So efficiency has already showing signs of improvement, so which has led to this situation where the carbon emissions are already getting saved. Second thing is that as soon as Ailu talked about this, about reducing your energy bills, but putting that into numbers clearly, that when this COVID-19 hit and we had this issues of supplies, issues of inflation rising very quickly, buildings with very inefficient technologies or with very efficient energy management were very poorly hit. And then there was a mess which was done around it, that if you could have done some efficiency improvement around it, you would have got enough money to meet your essential needs. So just a kind of a quick number around it, that for each 1 degree centigrade of reduction in heating, you could save potentially €122 of electricity bill as per some of the European countries' rates. So this is kind of a number that we are talking about, that it could really help. So in a way, reduce your temperature from 20 degrees centigrade for heating to 19 degrees centigrade at home. And just by this 1 degree centigrade change, what you will have is you will have further money in your pocket to spend on some essentials. So in a way, it gives you the money to spend. And I already talked about energy security, and just putting those numbers in perspective, that between 2000 and 2017, efficiency avoided about almost 11 exajoule of fossil fuel imports in IEA economies, and it's a huge kind of a dip which was observed through some of the technology interventions which has been seen in this, because these countries, remember, started working from 1990 on some of these aspects, and some of the countries who has woken up to the fact that energy efficiency can really lead to changes has really woken up to this fact. It is basically a service based concept. It is providing the same service using less energy. So in a way, it kind of converts into a service based model. We use services like illumination, thermal comfort, hot shower, cold drink. Services are coming, but the same service is now provided with lesser resources. So the quality of service doesn't change. So in a way, you are saying that you are improving your service model. The other way of looking into this is that you are in a way improving your service model, where you are now providing the same amount of service using less resources. That just for a comparison sake, you are getting the same quality of room at a lower rate. You are getting the same services, same clean bed sheet, same clean washrooms and all those things, but at a lower rate. That's effectively what is happening, because you need to put in less amount of resources to use it. So one of the biggest example on this is LED bulbs. I've been giving this example again and again during my course earlier also, that using the more efficient bulbs for lighting saves electricity. Unlike like just moving from one CFL bulb, so CFL may be also not a good as an incandescent bulb, LED bulb, you save about 75% or 80% of power. And just by this saving of this power, this gives you that money in your pocket. So you can then use this to spend somewhere else. It gives you more security. It gives you that carbon is reduced, but from a normal consumer perspective, that directly gives you power to spend that money somewhere else. So efficiency basically delivers the same service at a less energy. Therefore, efficiency is a demand side resource and not a supply side resource. So it is not changing anything from a supply side. It is not talking again about how energy is generated. It is about how energy is used as a service. It is working on that aspect of it. So I'll end my discussion for this class here today, and then in next class when we meet, we will start looking into understanding this difference between efficiency and intensity, and how intensity can be a misleading term for us to understand. Thank you.